Alright, let's prepare the answer key of quiz number 3, section 3, chapter 1. The first question is, an 805 kilogram car travels around a circular track with an angular speed of 0.118 per second. So this is the mass of the car. M travels around the circular track with an angular speed. So angular speed is given. This is omega. If the magnitude of the force that maintains a car's circular motion is 2,140 Newton, this is centripetal force, Fc. What is the radius of the circular track? Calculate R. So, equation for centripetal acceleration, centripetal force is Fc m r omega squared. This equation calculates centripetal force, but we have to calculate radius. That's why we should simplify. M and omega squared. To simplify them, we have to divide equation by m omega squared. So m will simplify, omega squared will simplify, so we will get R as centripetal force divided by m omega squared. So let's insert the given into the equation. R is equal to, centripetal force is 2,140. Mass of the car is 805. Multiplied by angular speed, but squared, 0.1, which is squared. We should get this into bracket. The denominator must be taken into bracket in calculation. Let's do it. 2,140 divided by bracket 805 multiplied by 0.1 squared, 0.1 squared, close the bracket, equals to 266. Yeah, 266 meters. So choice C is the answer. The angle between which of the following is 0? A. Centripetal acceleration, tangential velocity. On a circular path, let's show it like this. It's a circle. This is the center of the circle, and this is the object. Tangential velocity always tangent to the circle, Vt. Centripetal acceleration is towards the center. You see, they are perpendicular, not in the same direction. Angle is not 0. Angle is 90 degrees here. This is not correct. Centripetal force and tangential velocity. Tangential velocity is Vt. Centripetal force is towards the center. Let me show it with another color. Centripetal force Fc is towards the center. This angle is again 90, not 0. B is not correct. Centripetal force and centripetal acceleration. Yes, as you see, centripetal force Fc and centripetal acceleration AC are in the same direction, which means the angle between these two is 0. Centripetal force and centripetal acceleration. This is correct answer. Tangential acceleration, centripetal acceleration. Centripetal acceleration is towards the center. Tangential acceleration tangent to the circle. This is 90 degrees. So angle between them is 90 degrees. So this is 0 degree. This is 90 degree. This is also 90 degree. Choice is C. Question number 3. Blah 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 is the resultant effective force on a body that moves in a circular path and directed center of that circular path. So it's definition of centripetal force. Definition of the centripetal force in the book is given as the resultant effective force on a body that moves in a circular path directed towards the center of the circular path. Question number 4. An airplane is flying in a horizontal circle. The 95 kilogram pilot does not want the centripetal acceleration to exceed 7 times free fall acceleration. This is the mass of the pilot, m. And this pilot does not want its centripetal acceleration to exceed 7 times free fall acceleration. 7 times free fall acceleration means 7g, 7 times g. So this pilot wants its acceleration to be 7g. 7g. What is the net force that maintains circular motion of the pilot? So we know that net force that maintains circular motion of the pilot is centripetal force. Questions about centripetal force, calculate it. We will use the second law of motion because we know that centripetal force is equal to mass times centripetal acceleration. This is also known as Newton's second law for circular motion. So mass is given, AC must be 7g. And let's calculate first AC, 7g. 7 times g is 9.81. So it will be 7 multiplied by 9.81, which is equal to 68.67, almost 68.7. Let's round it, meter per second square. Now calculate the net force. The net force that maintains circular motion is called centripetal force. We will calculate that centripetal force. Mass is 95 multiplied by AC 68.7. So multiplied by 95. Answer is 6,524. Yeah, 6,524 newtons is the centripetal force, choice A. Question number 5. The inertia of the ball tends to maintain ball's motion in which path? Inertia, in fact, law of inertia, the first law of motion, tells that if the net force acting on the object is equal to 0, inertia is talking about that law of inertia, object's tendency is to follow a straight line path. So remember, when we are talking about the circular motion, if an object, for example, if an object is attached to a string to the center, if string and this object is moving in a circular path, if string is cut or break, the object will follow a straight line path, will fly off tangent to the circle because in the direction of the tangential velocity. So object's tendency is to follow straight line path. But remember, we said that this is the tendency of the object, inertia. This is called inertia. Tendency of an object to follow straight line path is called inertia. However, sometimes on the Earth, because of the gravity, we said that it follows parabolic path. But because of G, it follows parabolic path. There is a mistake. So general students think that it will be parabolic path. No. So inertia is the tendency of an object to follow straight line path, but on the Earth, because of not inertia, because of G, it makes parabolic path. So then inertia, when we are talking about inertia of the ball tends to maintain the ball's motion in straight line path. So we are not, this question is not talking about G, this question is only talking about inertia of an object, straight line path. So question number 6. A roller coaster car of 250 kilograms speeds down a hill. So at past point A with a speed of 15 meters per second. What is the resultant force acting on the car at point A? Resultant force in here is called centripetal force. Okay. Resultant force at point A is centripetal force. Definition of centripetal force, it's in here. Resultant effective force. Yes, resultant force is the centripetal force in here at A. This question is asking you to find centripetal force when the car is at point A. This car is moving at tangential speed Vt 15 meters per second, and its mass is given as 250 kilograms. Radius of the path is given as 10 meters. So calculate centripetal force. So Fc is equal to mvt squared over r. So m is equal to 250 vt squared. Vt is 15, but squared divided by r, 10. So let's use the calculator. 250 multiplied by 15 squared divided by 10 is equal to 5,625 Newton. This is the centripetal force, also the resultant force acting on the car at point A. Question number 8. A girl at a state fair swings a ball in vertical circle at the end of a string. So, vertical circle, like that. So, a ball is attached to a string, and it's moving on a circular path, like that. So, here is the bottom, here is the top. Question is asking, in what direction is the resultant force that causes the ball to move in a circular path, at the bottom of the ball's path, right here. So the resultant force that causes ball to move in a circle is centripetal force. It's asking you direction of centripetal force, and you know that centripetal force always points toward the center. So which one is correct? Is it upward? Is it downward? Is it to the right or is it to the left? So it's upward. Direction is upward. Question number 8. In a popular amusement park ride, a cylinder of radius 3 meters is set in rotation at an angular speed of 5 radians per second as shown in the figure. The floor then drops away, leaving the rider suspended against the wall in vertical position. Identify the force that maintains circular motion of the rider. So as this cylinder is spinning, rider is following a circular path. His body is following a circular path. So this is the center of the circle. There are two forces acting on the rider's body. One of them is gravitational, three forces. Sorry, one of them is gravitational force downward. The other one is static friction force. It is in the opposite direction of tendency of sliding, which is static friction force, and one more force acts on the rider. Rider pushes the wall of the cylinder. Wall of the cylinder gives reaction, which is normal force, Fn. And we know that Fn is perpendicular to contact surface. In here, contact surface is vertical. Wall of the cylinder is vertical. That's why normal force must be horizontal. Now question, which force is pointing the center of the circular path? Normal force, of course. Normal force by the wall of the cylinder. So this is the answer. This is the centripetal force. The force which points the center of the circular path is the centripetal force, and only Fn is pointing the center of the circular path. Question number 9. A roller coaster car moves through a vertical loop at a constant speed and suspends its passenger. This is one of the section 2 question by the time. The other one, the first one is chapter 2 question we solved in the classroom. So this is the vertical path, and the roller coaster moves through a vertical loop at constant speed and suspends its passenger. Suspend means it must be up there, right here. So what possible forces provide the centripetal force? So there could be two forces. One of them is absolutely exists. One of them is gravitational force. We know that gravitational force always acts down, and as you see, it's pointing the center of the circle. So by the time this is, of course, moving some constant velocity, constant angular speed. Second force is there is a surface in here. Of course, there must be extra reaction forces. So there must be track. Track must also apply a force on the car. Car is pushing the track up. Track is giving reaction down, which is known as normal force. Normal force by the track. Both are pointing the center. Why normal force is like this? Because normal force is perpendicular to the always contact surface. Contact surface in here is horizontal, so normal force must be vertical, downward. So both are pointing the center of the circular path. That's why both can provide centripetal force in here. Gravitational force, force of gravity, and normal force by the track. So choice is going to be C. This is not correct because also added here force of static friction, because force of static friction is in here parallel to contact surface. It will be like this or like that. So then it's not pointing the center. Force of static friction always parallel to contact surface, not perpendicular to contact surface. So this is Fs. It is not a centripetal force because it's not pointing the center of the circle. And question number 10. A copper block rests 50 centimeters from the center of a steel turntable. The coefficient of static friction between the block and the surface is 0.83. So this is a turntable. Let me draw in here. This is a turntable, and on this turntable, so it's turning, copper block in here. So this copper block is at some distance of 50 centimeters. So R, it's because as turntable turns, copper block also turns together with the table. So this distance becomes radius of the circle at 0.5 meters. And the coefficient of static friction between the block and the surface is 0.83. This is mu s. Mu s. 0.83. The turntable starts from rest and rotates with constant angular acceleration of 1.5 radian per second. So this is alpha. What is the maximum angular speed of turntable at which the copper block still stays on the turntable without slipping? So it starts from 0, initial angular speed is 0, but then speeds up, and because there's an acceleration. But after some angular speed, it will not stay there. But question is asking, what is that maximum angular speed? Still, this copper block is on the circular path. It's following a circular path. So in here, we did this. This is normally a part of the one of the chapter 2 question. Downward force is, Fg. Upward force is Fn. None of them can be centripetal force because contact surface is horizontal, Fn is vertical, Fg is always downwards. Static friction force in here. Static friction force is the centripetal force because it's parallel to contact surface and in the opposite direction of sliding. So we are going to write here centripetal force Fc is static friction force. Let's write them. Centripetal forces mr omega squared. We are going to calculate dead omega. Question is that. Still keeping the block on the surface, and maximum static friction force is mu s multiplied by Fn. So mr omega squared, we know that Fn is equal to Fg, which is m times g in here. Mu s mg, and m will simplify. Omega squared is equal to mu s g over r. After that, get the square root and calculate omega. Omega is equal to root of mu 0.83 coefficient of static friction. G, we know that 9.81 divided by r is 0.5. So bracket, because it's inside a root. So let's do this operation. Root of 0.83 multiplied by 9.81 divided by 0.5, close the bracket. Answer is 4. So 4 radian per second is the answer. For one of the following, the normal force is the force that maintains circular motion. Bicycle moving around the circular track. This is horizontal circle and horizontal surface. This is static friction force. Centripetal force in here. Friction. Pizza crust spinning in air. Cohesive force between the pizza doughs. Cohesive force. So it's not a normal force. Bobsled turning a corner. So when the bobsled is turning the corner, so bobsled climbs the wall of the track somewhere in here and then stay vertical. The surface becomes vertical. So if the surface is vertical, Fn becomes in horizontal, and Fn points to the center of the circular path. This is also one of the section review question. Bobsled turning a corner, so the normal force by the wall provides the centripetal force. Swing turning at a constant at some distance from the center of the right. This is tension in the chain or tension in the cord. Tension force. So this is the correct answer, C. As a driver makes a turn, the passenger is able to follow the same curved path as the car. So the force that maintains circular motion of the passenger. So passenger is in contact with the seat of the car seat in contact. So of course, the force acting on the rider's body, the passenger's body must be the force between the seat and the passenger. What force exists between seat and passenger? So in here, static friction force between the passengers and the car's seat. This is the correct answer. So other forces, is there other forces? Yes, of course. Let's say this is the seat. They say that somebody is sitting on it. This is the person. It's a box, but it's a person. Okay, the gravitational force always down. The surface is horizontal. Seat is horizontal surface. So Fn is up. So these two, but the passenger is following circular path in horizontal. So both are perpendicular to reduce. They cannot be effective. They are not effective force, but static friction force. Static friction force between the passenger's body and this car seat is the centripetal force in here. Question number 13. Consider a ball is whirled in a vertical circular path just in here. If the string breaks when the ball is at the top of the track shown in the figure, the ball continues. So what kind of path? Well, if there is no gravity, according to the law of inertia, a ball must follow straight line path if no gravitational force. But because Earth is a gravity, because of this gravitational force, so this ball will fly off this circular path tangent. However, later because of the gravity, it will follow a parabolic path. This path is called parabolic path because of the gravity. Question number 14. Two identical balls attract one another. By what factor does the force change if the mass of each ball becomes half of the initial mass? So you know that gravitational force is proportional to product of multiplication of masses, mass 1 and mass 2. If both each mass becomes half of initial, so we will make m1 half. Instead of m1, I'm going to write m1 over 2. Also, instead of m2, I will write m2 over 2 because both of them, is halved. Both of them are halved. Each ball becomes half of initial mass. So then continue. m1, so this is multiplication. So numerator m1 times m2. But denominator becomes 2 times 2. You will multiply them. 2 times 2 is 4. So compare them. So what you did? You divided m1 times m2 by 4. So force must decrease by a factor of 4 or must change by a factor of 1 over 4 because this f over 4 is written 1 over 4 multiplied by f. This is change 1 over 4. And question number 15. Find the magnitude of gravitational force F 67.5 Newton kilogram per person would experience while standing on the surface of Mars. So this is about the Mars. Here is the Mars, center of the Mars, mass of Mars, and a man is standing. Somebody is standing in here on the surface. So that man is small m, and mass of that man is 67.5 kilogram. And the mass of Mars is given as 6.34 times 10 to the power of 23 kilogram. And the radius of the distance between these two masses is radius of Mars. Radius of Mars, it's given as 3.43 times 10 to the power of 6 meters. So calculate gravitational force, magnitude of the gravitational force, Fg. You know that Fg can be calculated by capital G. First mass of Mars. Second mass of man, divided by separation between two masses, which is the radius of Mars, but squared. Okay, G, 6.67 times 10 to the power of negative 11, multiplied by mass of Mars. How much mass of Mars? 6.34 times 10 to the power 23. Mass of man, how much? 67.5. sorry, 67.5 divided by square of radius of Mars. What is radius of Mars? 3.43 times 10 to the power of 6. Yeah, it's radius, but squared. Squared. Then let's do it. Calculator. 6.67 times 10 to the power of negative 11 multiplied by 6.34 times 10 to the power of 23 times 67.5 divided by bracket 3.43 times 10 to the power of 6, close the bracket, but squared. Answer is, we got it. It is so big number. No, pardon, not so big number. For 242.6. 242.6, which is 243 Newton. Almost. Yeah, A is the correct answer. Two objects with two specified masses and then specified distance separates them. If the distance between them increases by a factor of 3, by what factor gravitational force between them changes? This is about distance, because we know that according to the equation of gravitational force, which is G m1 m2 over r squared, force is inverse proportional to square of the separation. So Fg is proportional inverse square of the separation, 1 over r squared. Question says that separation between them increases by a factor of 3. So r changes to 3r, increases by a factor of 3. Means this, r changes to 3r. Now in here I am going to write instead of r, 3r. So let's write it. So 1 over 3r squared. I have to square both of them, 3 and r. So it's going to be 1 over 9 square of the 3 is 9 r squared. Now compare these two. We divided the first one by 9. That's why force also must be divided by 9. So 1 over 9 r squared. Which means force decreases by a factor of 2 or change. 1 over 9 multiplied by F changes by a factor of 1 over 9. So this question says change. That's why we should give the answer by 1 over 9. Free fall acceleration, question number 17, on the surface of the planet is. Let's write the equation for free fall acceleration G. It is like this, capital G, mass of planet divided by radius of the planet squared. So it was like this. Directly proportional to radius of the planet. No, it's inverse proportion. It's because r is in denominator, not numerator. G is inverse proportional radius, and even its radius in here it's squared. Not correct. Inversely proportional to radius of the planet. No, inverse proportional square of the radius, because in here square, not only r. This is also not possible. Inversely proportional to square of the radius of the planet. This is correct, because G is proportional to 1 over r squared, not only r square of the radius of the planet. Generally mistake is this mistake is done, I think, B. But in here square, how can you say it's directly inverse proportional to radius? No, inversely proportional to square of the radius. Square of the radius. Directly proportional to the mass of the fallen object mass. No, directly proportional to the mass of the planet's mass, not fallen object mass. Planet, this is planet's mass. So this is correct answer. C is the correct answer. And question number 18, universal gravitational force between two objects. So it's talking about this equation. Fg is equal to capital G m1 m2 divided by r squared. So Fg is directly proportional to square of the distance. No, inversely proportional because it's 1 over. It's in denominator. This is not correct. Inversely proportional to product of the two objects' masses. No, directly proportional because m1 times m2 objects' mass are in numerator. Fg and m1 times m2 directly proportional. This is not correct. Inversely proportional to inverse square of the distance between two objects' center of mass. So inverse square to inverse square means 1 over r squared. So it becomes r squared. No, this is not correct. So because r must be in denominator, not numerator. Inversely proportional to square of the distance between two objects' mass. This is correct because this is saying that f is proportional, inversely proportional to square of the separation, 1 over r squared. This is correct. Question number 19. According to early model of the universe. Early model means very, very old model of the universe. Remember, scientists were thinking about that. Earth was the center of the universe, and all other space objects are bodies, planets, stars, and all other things are revolving around Earth. That was the belief in the very, very early time, before Johannes Kepler. Answer is A. In equation G is equal to capital G mass of Earth divided by r square of the Earth, G represents, G is the universal gravitational constant. Universal gravitational constant, constant of universal gravitation. So according to that, this is universal gravitational constant is G. And sometimes students get confused. This is free fall acceleration, small g, or acceleration of gravity is small g. Gravitational velocity is small g. These three are defining small g, which is different. But that the universal gravitational constant is defining capital G, which is in the equation. So this is the solution of answer key of the third quiz.